So we got recording. We've got closed captioning. Now I just need to share my screen. I need a better default single screen here. Let's do. Let's do it like this. All right. We'll give people another 2 minutes maybe. Although, yeah, we've got quite a few people. Everybody's coming back. I guess you must like me. Well, yeah, today we'll go through our first kind of example game. I put in the notes, and I hope everybody saw it. We want Unity 2019.3. There were a few issues, just content that's on the education portal where the examples don't run in 2020 yet. A lot of it has to do with the different plugins and packages. So Unity itself, yeah, it has a number of packages and things, and some of them just haven't been brought over or updated to 2020 yet. So we'll use 2019, I guess, for now. I think in our first class we're just going to use 2020 beta. But that was yeah, I should have looked at the content in the education part of the Unity website a little bit more. I think, yeah, we just want to go with 2019 for now. Yeah, so the game that we're going to be using or kind of going through tonight, you get there, you open up Unity, and there's even a Learn tab here now. And the game that we're going to be learning about is this platformer micro game. So you want to go ahead and click on that and then download the project. I've already got it downloaded. If I click on it again, it'll download it again. But yeah, you download it again and you open up the project. It'll probably just open it again. And create a new project. So yeah, I guess while we're still waiting for people to show up, go ahead and get the project downloaded so we all have an environment that's the same. I hope everybody's staying safe. One of my friends actually was down by the White House yesterday and got hit by a rubber bullet. So yeah, it's a little bit dangerous out there. It's also a pandemic going on. Anyhow, importing packages. It's actually a little slower than I thought it would be. There's must be a lot of resources and things in the game.
Justin?
Yep.
Can we ask some questions before start? Like
Yeah,
general
sure.
questions?
Let's definitely. Yeah, I should have
Sure.
asked that actually from the beginning. If people had questions on the assignments, what they got stuck on, because yeah, the stuff that I assigned you guys, there was a lot of content, so I'm not sure how far everybody made it through that stuff.
Yeah. So I was gonna ask a little bit related to that. It's in this process that we are learning more and more about Unity and 3D and all that. I'm interested into learn more about VR. But what would you be your advice right now that I have been trying to purchase an Oculus Quest since like a lot of months, and it's always there is no product of it, because if you try to purchase on their website, it says they will notify you when they have some available. And if I look for them on Amazon and things like that, it's like they have a very high price, like 500 or more for just
I
one device.
Yeah, I pretty sure they're selling out of the hardware now. The sales weren't very large in the beginning, but since the COVID crisis kind of set in, people are looking for more and more things to do at home. And so I think they are kind of hard to come by now. You could go on to the Best Buy's website, look on Amazon, look on Newegg, might have them. You could even try eBay. You might not be able to find a brand new one, but even if someone's only used it a few times, it should be, or even a lot, it should be in pretty good condition. But if people are using their Oculus a lot, they're probably not selling it, would be my guess. So the ones that are available on the secondhand market probably haven't gotten used very much, and that's why they're being sold. So
Got it.
yeah, so this is the project. Seems like it automatically called it new Unity project. I'm wondering where it saved it to. Did I put it in my desktop? Where did it put? Usually I put all of my projects into Unity projects, but So where did it save it by default? Oh, that is an icky spot. Really? Wow, it saved it to a temp directory in my app data. That is not a good place to save a Unity project. Yeah, that's not a good place to save a Unity project. As I told you guys last week, whenever you download something from the Unity App Store, it saves it to your user profile, app data, roaming, Unity, App Store, and here is the package right here. So this is the game. I would recommend starting like a new project, and then once you've got your project open, and save to an appropriate location, then you can right-click on your project. You can do import package, and then import that custom package. And then, yeah, save your project to an appropriate spot. Otherwise, it looks like by default, it puts it in this weird temporary directory, which is not a good place. Yeah, if you did do it this way, I would recommend going to this location and just moving the whole directory to somewhere better, like your desktop or wherever you keep your Unity projects. Because yeah, that temp directory is not a good place to keep it. So yeah, you'd take this whole thing and you'd move it to somewhere better. I already have a folder on here in my Unity projects called Day 3. This is where I put my assets, but yeah, I would move all of this stuff to an appropriate directory. I'm just gonna keep with my Day 3 project here, but yeah, make sure that your project is saved to an appropriate folder and not some weird temp directory. I'm just gonna get rid of that. And yeah, Unity creates a lot of files. A lot of them are actually in the library. The library is kind of there are a bunch of temp files. You could actually delete your library, and when you opened up Unity, it would rebuild your library for you. And as I mentioned, if you're using versioning control, do not check your library into versioning control. Unity creates it automatically. It's almost like a cache of things that the editor uses. And so, yeah, you don't put it in your Git repository. Were there other questions? Just want to make sure. Yeah, if you guys got stuck on anything.
Yeah, for some reason, when I try to move the files over, it says it can't transfer a Unity lock file.
Make sure that you close down Unity when you move the folder.
Yeah, I have. For some reason, it's still saying that it's open. Yeah, that it's open.
Try.
Actually, it says the file is no longer in there.
Is it what? Does it say what specific file?
Yeah, Unity lock file.
Unity lock file. Yeah, make sure you have Unity closed, and if it still thinks that it's
Well, now it says it doesn't think it has it open. I have it open. It just says like it's no longer located in there.
So when you go to open it, make sure that you're opening the folder. There isn't necessarily like a Unity project file. What you do is you point it to the folder that contains the assets folder. So in this case, it's my Day 3 folder. Does that make sense?
Kind of.
This solution file, that's actually for Visual Studio. That gets auto-generated. But yeah, when you, let me back up and just close out my project here. If I were to open up a new Day 3, this might not be here. Let's just remove it from the list. Yeah. And we want to add it now. I'm already at the folder, but yeah, you pick this folder and then you can select folder and then it adds it to this list and you can just pick it. Any other questions? All right, let's kind of dive right in then. So this is a 2D platformer game. If you hit play, it actually works right out of the box. You can move and jump. If you run into the slimes, you die. If you jump on them, you kill them. I didn't get real far, but yeah. So let's take a look at our hierarchy and see what's in the scene already. We've got a game controller here, and it uses the Cinema Machine, which is a relatively new Unity feature function. It's introduced maybe 2 years ago, where you can use it to do really cool things with the camera. In this case, the Cinema Machine is used to control our camera, where it, if you're moving one direction or another, it kind of moves it with him. But notice how even when I stop running, the camera kind of catches up. And those are properties that are set with the Cinema Machine, which is a little further down in our tutorial. Someone just said that it's taking a long time to import. Yeah, let's slow down a little bit and make sure everyone's got the project open so they can follow along.
I almost want it to be faster if you would just like export a package and we import that package of this.
Export this package.
Yeah. Like a little thing on Slack.
I haven't really added anything, and so it would import just as fast. I mean, this is the package. I haven't really altered it, and so if you were to import this one, it would import at the same speed. I don't even know why it's going so slow. It went pretty slow for me as well. Looks like they have a lot of animations in here. They've got some audio files. I don't know how big the audio files are, but let's see. How big is the project itself? It's only about 40 megs. A lot of those import settings might have to do with the optimization of the Cinema Machine. Unity does a whole bunch of optimization stuff on the back end to try and get things to run faster and so that it can run its profiler and things. We didn't even really get into the profiler yet. The profiler can be used for memory management and optimization. Yeah, I'm not sure if we'll even get into that type of stuff during this course, just because it's really for tweaking a game rather than building a game. I'll at least show you guys the profiler. But yeah, you can be found in, I think, General, or it's more of a debug tool. So analysis probably. There's the profiler. And the profiler gives you a breakdown of how your game is using memory. This can be used to identify memory leaks. This can be used to see where, system resources are going. It's kind of a memory hog too. Like if you've got this thing running in a window on the side, it will probably slow down your game just because it's tracking so much information. Usually you just kind of need a little snapshot of what you want to try and diagnose. And then, because you can go back and even see, individual script files and how much they're taking. You can see if it's going to the GPU. There's a lot of different things and information you can get from this. Especially if you run the deep profiler, you can see all the call stacks. There's really a lot of information you can derive from the profiler if you need to. But if your game's running smoothly and You don't have to do any of that. Yeah, you might never use the profiler, but I've had to use it a few times in the past to identify where we were having memory leaks, where we have a solar system simulator and it kept generating like 40,000 asteroids every frame or every time you refreshed it, and so we were able to identify that problem in the profiler. Yeah, there's some audio files in this project.
Hi. Excuse me, Justin. Could you go back to where you got the game from? I must have
Sure.
downloaded the wrong game.
Yeah,
or blank.
no worries. If you open up Unity, actually, let's not do it this way because it ends up installing it to a directory it shouldn't. I'm going to go ahead and put the Unity package onto the Slack just because then you can grab it from there. Right there, if you want to download it. And then you should be able to just take the Unity package and drag it into your project, or right click on your project and do import package, custom package, and then select the package and then hit open. It'll uncompress it. If I do it now, actually, it'll even tell me that I can't import during play mode. But if I turn play mode off, it will still probably tell me the contents and that probably everything is about the same because I haven't changed much. Yeah, normally you'll see little green things that say new. If you don't have it, you'll have these little circular things if something got updated. I don't even know what got updated on these PNGs. Maybe a timestamp or something. I'm not even sure. No news or anything. Looks like maybe some of the asset files got different metadata or something. I mean, I could re-import these, but all of the files are pretty much the same. Actually, I think I did try editing the health. I was playing around with the game and stuff a little bit before we started, and this would be the only one. Maybe change some things in the scenes. But yeah, you should be able to import this package and basically be right where I'm at right now.
Okay, working on that. Thank you.
Yep. So let's see here. What else do we have in our project? We've got sprites and animations. We've got documentation, which we could delete, but we'll just leave it there for now. Remember, I told you guys editor is a special field. Seems like, yeah, this editor script is creating a special Gizmo, looks like, where you can draw handles and things. And I told you Gizmos are the kind of the little widget looking things that are in your Unity scene. You can turn them on, turn them off, but they're just kind of there to help the developer pick things out in the scene. Yeah, I'm gonna guess, yeah, if we maneuver around here, this line here looks probably like the gizmo that that is being generated by the patrol path editor. Yep, it's drawing this dotted line and it's drawing these disks. And yeah, it's basically a helper function to show, I bet this bad guy patrols back and forth right here. And so the editor code is just kind of there to help the developer see, yeah, what's going on. Because I imagine you don't get a whole lot of guidance from the enemy patrol paths. Yeah, when you look at it here on the inspector, it just, you've got numbers, but then you don't have anything that really helps you to give you an idea of how long this patrol path actually is, and so that's why this editor script helps us out quite a bit. Inside of our environment folder, environment's not really a special folder name, but usually it helps if you've got a lot of files to start making folders to keep things straight. It's a whole lot easier too if you're working on a team. You know, if you're working with just yourself, then you know you can organize it any way you want. But if you are working on a team, you want to have some consistency as to where you put your resources. I would advise against putting all of your models and materials into the same folder. I did that when I first started working in Unity, and it just ends up not being very good. I would not put all of your textures and models and materials into the same folder. Mod assets. Ooh, wow. This is probably what's taking up all the space. These are prefabs. You can tell what a prefab looks like, or which ones are prefabs, because it's got this blue box. All of the different major file types that Unity supports have different icons. They used to have all the texture files have the same icon. Now it kind of looks like all of the texture files actually show the texture, which is, I guess, useful because you can see it. You used to have to kind of click here and look in the inspector and see what the image looks like. Now it actually, for all of the textures, it shows you what the image looks like. As far as materials, materials are usually a sphere, and the sphere will be whatever color the model is, or whatever color the material is. And prefabs are basically game objects that you've brought over from your hierarchy. You know, kind of rehashing some of the stuff we talked about last time and in the first class. But yeah, they're really useful because they're kind of like cookie cutters that you can use to add things to your scene, where over here in your hierarchy, you see all of these enemies. They're more or less the same, but they're in different positions. Looks like they might have different speeds. If I wanted to update all of them, so if I wanted to make all of my enemies a different color, I could come over to the prefab, the enemy prefab, and if I want to change all of the enemies from red to blue instead, or orange, I could take this prefab, I could open up the sprite render, and rather than having this default material, switch it to a different color material, and then all of the enemies in the game would change to a different color. We'll do that kind of at the end of the class, maybe as a example to make sure that people have an understanding of how powerful the prefab system is, because you can actually nest prefabs now. So prefabs can have prefabs within themselves. You couldn't actually do that until, I think, Unity 2018 came up with a new prefab system, and it's really powerful. So we've got our scene, we've got our scripts. Wow, there's quite a few scripts here, actually. Most of them are probably not real long, though. Yeah, they're pretty short. A lot of this is just code comments that explain the variables. Some people use more code comments than others. I kind of have the mentality that if you name something really well, it doesn't hardly even need a comment. I like to use really long descriptive variable names. A lot of the people in this class have been programming, so I'm not going to lecture too much about programming style. By this point, you probably have your own programming style, but yeah, those are the. I do usually put all my scripts into a single folder, and then you can create additional subfolders depending on either what scene those script files pertain to, or what the scripts, if they all do some kind of functionality or some kind of menu control, then they probably belong into the same subfolder. TextMesh Pro is actually a Unity package. I don't know why this didn't get included in Unity packages, but yeah, it's basically a UI design plugin that allows you to have cool fonts and texts. These tiles, what are these? I think they're just graphics. Oh, they might actually be scriptable objects. Well, I guess we might get into scriptable objects tonight. Tutorial info is just icons and sound effects. Probably don't need. And then, oh wow.
What are scriptable objects?
Scriptable objects are, that's a good question. Let's go get a better definition than what I would give scriptable objects. I can read you this and then I'll give you a better, maybe more layman's version. So scriptable object is a data container that can be used to save large amounts of data or small amounts of data, independent of the class instances. One of the main uses for scriptable objects is to reduce your project's memory usage. You can use it in your projects for prefabs. Yeah, basically they are objects that can keep information, configuration information. And so rather than hard coding a bunch of variables inside of your script, you can keep that information in a scriptable object. And so just like mono behavior, scriptable objects are derived from the base Unity class, so you can call them, but unlike mono behavior, they cannot be attached directly to the game object in the hierarchy. You can only really call them or drop them on in the inspector. So,
got it. So like
yep.
A scriptable object will be like a tree, and inside of that script you have like, you will define like in a class how many left, how many branches do this
exactly
tree
yep.
has added.
Yep, exactly. Well, I thought that was going to be harder to explain than I thought. Because yeah, scriptable objects are not always the easiest thing to understand, but they're basically kind of like a configuration file for one of your mono behavior classes. So
got it.
yeah, there's lots of examples and stuff. We'll get to the example that's in the game, and it looks like these are scriptable objects as well. I think these were actually, so when I opened up the project the first time, it popped up like a little tutorial thing. And I think these scriptable objects are actually configurations for that tutorial, is what these are. Yeah.
Got it. Thank you.
And it looks like there must be an editor folder somewhere. And you can always search your project. If you do editor here, it will show us all of our editor folders. Oh, there's only one. Because I thought this did just the gizmo, but it is perhaps also doing the tutorial. Something is creating this tutorials thing. At any rate, there's some code in here that is creating this tutorials drop down, and then when you do show tutorials, this information right here, I think, is all created by scriptable objects. So they are very powerful, and Unity has actually been pushing them pretty hard. Some programmers like them a lot. I haven't used them all that often. But yeah, it seems as though we're going to be using them tonight in our game. So yeah, they're scriptable objects. So does everyone have the project downloaded now and opened up? I want to make sure that everybody is caught up and not still waiting on their project to import.
I currently have it open.
I have it downloaded, but not open. Should I be seeing the scene that you have here?
Yeah, you should be seeing this. This is what you want to see in the scene view anyhow. I'm not sure if your layout is laid out exactly like mine, but if you look at the scene view, you should see something similar to this. Your hierarchy should look identical to this, and even, yeah, your project should look like this as well, because I haven't really changed anything yet so far.
So how do I get it open? It's definitely downloaded. It keeps telling me it's downloaded.
Yeah, sure. So go ahead and do you have a new project open? Do you have
yes,
like a
the one
blank?
that you put on the Slack? Yes.
Oh,
I
so
did all that.
When you double clicked that Unity package, did it open up this, or did it open up something that said import? Oops. Did it open up something that looked similar to?
Yeah.
Does a decompression, and then yeah, there's an import button.
Right. Did all that.
And when you hit import, it does everything. And then after it gets done importing, it should look like this, right? Or not?
It does not. So
do you have files?
It
Do you have things in your project here?
I had, yes.
Or is it?
But
oh,
I don't
you do have
the
this
scene. So let's figure that out. I don't have
yeah, if your scene isn't open, then you just have to open up your scenes folder and then double click on sample scene, and it should open it. Yep, seems like you got everything imported. You just had to open up the scene. And so yeah, we can experiment around. If we use Q, or if we hit this little hand, we can move around and kind of look at the level, it looks like the level is pretty interesting. We click 2D, but if you want to click, if we undo 2D, you can actually look at the game in 3D as well. Yeah, it's a 2D game, but everything's kind of on this flat single plane. And so we'll just lock it back to 2D. Yeah, if you want to, zoom in on a particular enemy, you can double click on an enemy. Can leave gizmos on or gizmos off. It's kind of your preference if you need additional information or if you want to see all that. Sometimes the gizmos get in the way. So yeah, everyone's got the scene open now, I think. Let's continue going through the hierarchy and making sure that we understand what's here. This is the player controller. If we double click on game controller, so the game controller has a number of scripts attached to it. All of these are attached to our game controller object. And so if we want to see the properties, we can drop them down, or if you double click, then it opens up the script itself in your IDE, in your editor. And you can see here, looks like they're using a singleton type deal here. If you're familiar with different programming patterns, singleton is basically a pattern that ensures that you only have one game controller. Yeah, singletons are useful. In our Space World game, we've got a singleton called menu controller that keeps track of all of the menus. Yeah, it doesn't look like there's too much functionality in here in this game controller even. Let's look at some of the other, one of the, doesn't look like it has much, but one of the properties that's in here is the platformer model. And so this platformer model has a lot more properties in it. It's got the cinema machine itself, which is used to control the camera. It's got a reference to the player controller. It has a spawn point, which is basically where you come back to life if you die. And so if you wanted to, change where the person regenerated, you could change that spawn point. Right now, it looks like that spawn point is, you double click and it looks like it's right here. But if you wanted to spawn later in the level, or if you wanted to spawn additional or have additional spawn points, you could do that here. This is where you do that. Looks like we have a jump modifier here. Yeah, in Visual Studio, if you push Shift F12, it tells you all locations where that particular variable is used. Yeah, I don't know if you guys are interested in me dropping the different hotkeys and things that Visual Studio uses, but yeah, if you use Control Shift F, there's a global search where you can search for particular keywords. Shift F12 looks for all instances of a particular variable, or if you just use F12, then it goes to where you actually declare the variable in your class. And so, yeah, our game controller's got a little bit more information inside of the model itself. Looks like there is a token controller. This I'm going to guess is probably these little tokens that you can pick up for points. The Metagame Controller. This seems like, I'm not quite sure what this is yet. It looks like they created some kind of metagame controller to handle switching controls between high-level context of the application, i.e. the main menu and the gameplay. So this is metagame controller is basically for handling the main menu and switching back and forth between the main menu and the game itself. Yep, that's all that really does. I don't know why they didn't include it in the main menu controller, or maybe that actually is the main menu controller and they just decided to call it metagame controller instead of main menu controller. This is our UI canvas. This is the heads-up display, the GUI. Looks like it has a script on it as well. This is kind of the main menu controller right here. This handles the different sub-menus of the main menu. It looks like there's probably a settings and a controls and a credits. I didn't even really see how they activated that. Was there a menu button? I don't even know. It doesn't look like there's a menu button, but if we want to turn it on, we can just do it like this from the editor. Ooh, that doesn't look readable. There's probably something in the script file that, well, when I stretch it out, it looks a little better. But yeah, that's how we cheat and turn the main menu on. I'm sure if you turn it on the way it's probably supposed to be turned on, the script sets the sub-menus appropriately, because I think when I just turn it on like this, all of the things get turned on, or yeah, it doesn't get set appropriately because I'm cheating by turning it on in the inspector. You know, because you can, yeah, the inspector can be used if I want to hide my main character. You know, I can just go to player and nope, I don't have player anymore. So yeah, and don't forget, you know, any changes you make when you turn the game off, they get undone, and so our player comes back to being turned on after we turn it off. So yeah, that's the UI canvas there. It looks like there's main menu, settings and things. We won't go into the nitty-gritty of their UI right now. Yeah, the Unity canvas is powerful. It can do pretty much everything you need it to do. And it didn't always exist either. It wasn't introduced until Unity 5. There was a couple of third-party packages out there, Daikon Forge and NGUI, that people gravitated towards because they were Unity packages that you could purchase for $50 or $100 or whatever, and they work pretty well. But now that Unity has introduced Canvas, yeah, those packages I think are a lot less popular. Here's our main camera. So if we turn this off, we're not, yeah, the game itself will quit working because you need a camera or your game won't work. We kind of learned that lesson last week the hard way, where we couldn't even do a GameObject.find without having a camera in the scene. Looks like it's got an audio listener as well. Usually, yeah, you want your camera to have the audio listener. You could put your audio listener on a different game object, but then so Unity has 3D sound, and so if your audio listener is not where your camera is, you would be hearing sounds that you couldn't necessarily see. And so usually that's why the audio listener goes on the main camera, just because, yeah, I would say 99 times out of 100, you want your audio and your visual to match up. Here's our cinema machine brain. These are properties you can use to change how your camera reacts. And yeah, I'll kind of leave it up to you guys to, play around with the different properties. That's not so useful. Sometimes, yeah, the show debug information in GUI actually gives a lot more information than that. This event system is used also for the canvas. This base input, though, this is also part of the Unity engine. I think it's just handling the mouse buttons, it looks like. Didn't realize this game actually had a mouse. The mouse, yeah, the mouse would just be for the heads-up display for the main menu. This is a virtual camera. I think this is probably used for when you die. The camera scrolls back to the respawn point, if I had to guess, and then it follows the player around. This seems like a box collider, or rather a polygon collider to handle where the camera goes. Cameras are probably the most tricky part of a game usually. If you want to make a custom one anyhow. There's a lot of cameras out there. The first person shooter one's probably the easiest just because you're just behind the gun, but then yeah, if you want to add kind of like a bounce, for when your player would be taking footsteps, that's a little more challenging. But yeah, a lot of times it's just easier to find a camera that somebody else has built and use theirs. Yeah, I've done some custom camera creation, and it's just a lot of work. It's a big challenge. You have to know how to do vector calculus because you're dealing with quaternions and Euler angles, and yeah, there's a lot of complex vector math that goes on when you're trying to create your own custom camera. This is the player itself. It's got player controller, probably one of the more important scripts. Look at all those properties. We'll go through this script once we get finished going through the hierarchy and see. Yeah, this basically controls your player. It's going to be all of the different things that happen, audio sounds that get played, your player health, what happens, the jump state that he's in, because this probably, my guess would be that this variable controls what animation is being shown. You've got the sprite renderer here, which is the actual image. Yeah, if we wanted to change his color, you could change the color here. It looks like, yeah, the sprite renderer is being updated every frame based on this animator. The player has an animator here. This is, we'll go into the animator too. The animator is a pretty important function / feature / system that's within Unity. Note that there is a difference between animation and animator. The animator system kind of is a state machine that shows the different states at which the animation can go. And then the animation are kind of pre-recorded states. So these animations go, each of these is a animation that is in the animator. And so, yeah, we'll go into that a little better. I think I definitely want to try and find some kind of video example to explain that. They used to have really good ones on the Unity website. It was a lot more organized before. I don't know why they changed their education stuff so much. I feel like it used to be a lot easier to navigate. Now you have to use all these search bars and stuff. But let's see here. What else is on the player? We've got our sprite. We've got our animator. We've got our rigid body, which is the thing that gives it gravity. And it's also important to have a rigid body. Otherwise, you can't collect. You can't have a collider. You need a rigid body to have a collider to know that you're getting hit by something. There's a health script. I'm actually not entirely sure why they didn't merge the health script with the player controller script. Oh, it looks like the player controller script actually has a reference to the health script. And so, yeah, still don't know why they didn't merge those, but they're on the same game object. Perhaps they put this health script on the enemies. No, enemies don't even have health. So, yeah, I'm not sure why they did that, but maybe we'll figure it out as we go through the scripts manually. This is the spawn point. So yeah, your transform doesn't, your game object or your transform doesn't necessarily have to have any scripts on it. A game object always has a transform no matter what. But that doesn't necessarily need to have any components. This is just this, you know, game object exists because it has a position, and the position is where the player gets spawned if they die. So if I double click, you can see exactly, you know, back at the beginning of level is where you spawn. Grid. This is interesting. I've never actually used the grid before. It looks like it's a Unity, built-in Unity class. Because normally the difference, the way you tell a difference between something that has been written by a programmer and not part of the Unity engine itself is that you'll see the script name here, and you can double click on it and it'll open it up. When you click on the grid though, see how there's no grid.cs. You can still click on the ... and do, usually you can do edit script and it will at least give you more information. It looks like if we want to figure out more information about these grid classes, we'll have to come over to our documentation. We're already in the documentation website, so we can probably just type in grid here rather than going all the way back to Google. Although sometimes, here it is. Unity's search engine works pretty well. Sometimes Google's search engines works better than the actual website's search engine, but in this case, Unity found all of the grid things. If we click here, yeah, these are the properties that we see over in our inspector here. Looks like the grid is kind of just there, maybe even as a just a reference. I'm not sure. Oh, yeah, there's something in the code that is dependent upon the grid, because if you don't have the grid, bad things happen. You die. So yeah, we'll leave the grid there for now. I'm sure as we look at the code a little deeper, we'll come to understand how and what this grid is doing. Looks like here's the background. Creates a parallax layer that's, makes it so that the background moves slower than the things in the foreground. So it makes it seem like it's further away. It's kind of a cool little camera trick. I'm pretty sure we shouldn't need the background. Well, that's interesting. I would have thought the background actually disappeared, but looks like the background's just, it's being rendered by something else. Yeah, there is no sprite renderer there, so it seems as though this background object is maybe just for even Cinema Machine works. Yeah, I'm not quite sure what that background variable is for. We can figure out. These are the enemies throughout the level, looks like, and they are all, let's turn our game off. Way all of our prefabs pop up in blue. And yeah, it looks like all of the enemies, of course, have sprite renderers so that you can see them. They have rigid body and colliders so that you can run into them. And then they also have animations. And then probably the most important or the most customized script is the enemy controller, which it looks like there's this path property and then a sound when you land on the enemy. The path property, these are referencing different game objects. And so these game objects, have the start and end position. There's really not too much to this script. It's basically two vector twos. Vector is position, basically. If it's a 2D vector, then you have an X and a Y. If you've got a 3D vector, if we got a vector 3, then it's a X, Y, and Z. So these enemies, I'm sure, have corresponding patrol paths. Otherwise, if they don't have a patrol path, my guess is that they just sit there and don't move. These are all the different tokens throughout the level that you can pick up. They also have sprite renderers so that you can see them, colliders so that you can run into them, and then token instance. This is probably what happens when you pick them up. My guess is that they keep there's a variable somewhere that keeps track of how many tokens you've picked up. On player enter, yeah, I'm gonna guess that, yep, collected is the magic variable name. I know collected is a true false to see if it's actually already been collected. The variable that keeps track of the number of tokens collected, my guess is probably on player, or on the player controller. Or maybe not. Maybe it's kept somewhere else. So I was just looking to see if we can't figure out where our token count is being kept. I would have guessed that it was on the player controller. Was there something else on player that might have been keeping track of our token count? Or maybe it was on the main token controller. There it is. Yeah, token controller is what keeps track of our tokens. Yeah, let's go back and can do a global search here for token controller. It's like, oops, oh no. Our token controller is being incremented here inside of our token instances, and is being incremented right down here in on player enter. So yeah, controller is the controller that's keeping track of the tokens. And this is why it's important to use better variable names, because we looked at this and we kind of knew that the thing that kept track of it was in here somewhere. If we had called this token controller, we would have immediately known that it was the token controller, rather than having a variable name like controller, which is just what does it control? And so yeah, control RR is refactor. Refactoring is like renaming, except for it goes through and it finds all instances of this controller in your project, and it renames it to token controller. There. Yep. All instances token controller. It's Unity's thinking a little bit. It's also, the editor itself is coming to understand that we just refactored the token controller. Let's go ahead and make sure that our game didn't break. Usually if you refactor stuff, Unity's pretty smart, but let's go ahead and pick up a token, make sure it works. Oh, good. Let's see here. We made it down to zones. Ooh, it looks like death zones might be something that updates where the player respawns, perhaps. Death zones are mark a collider. Yeah, they seem probably like maybe little save points or something.
I think the death zones are the pits.
Yeah, you're right. That sounds.
Yeah, considering
that
where
sounds correct. Yep, and then whenever you enter a pit with your player, you schedule a player enter death zone, which I'm gonna guess kills the player. Yep. Yep, they're the pits. Victory is probably gives some kind of cool animation, and it signals that you're at the end of the level. And then alien. Wow, there's an alien somewhere too. He might be the boss or something. I'm not sure how you get down to him. If anyone's actually beat this level, I don't know how this alien interacts with the game, but he doesn't look very happy. He's kind of stuck down in his cave there. Or maybe he just sits there. I'm not quite sure. He doesn't have any scripts on him. All he has is a sprite render and a collider. So who knows? I don't remember seeing any properties that reference the alien. So yeah, let's go through our player controller real quick. We'll go through the player controller and the enemy controller, and then we'll stop for questions. And then I might give you guys a couple of exercises just to make sure that you're understanding how the hierarchy and the inspector work with one another. So yeah, our player controller, all of these properties here show up in the inspector as long as they're public. They show up as private one. Stop jump does not exist over here in the inspector. The awake function, and actually I feel like I didn't talk about this enough. The awake function gets called whenever your game starts. Unity game flow. Is that game flow chart? I was gonna find this before. Here it is. I didn't even need to look it up because it comes up first because it's that important. If you Google search Unity game flow chart, this flow chart is pretty important. It's everything that happens when you push play. So when you push play, all of your mono behavior scripts that are in your scene will call awake. If the game object is on, it will call on enable, and that's you would write that right here just like you would write anything else. You do void on enable. The text is even telling me, yep, that's something you can do. This gets called, yeah, whenever your game object gets enabled. There is a reset. Doesn't get used very much. I think it's basically something that's used in the editor. If you're writing editor scripts, there might be a restart. Start is an important one. Start only gets called once for a given script. And sometimes it's important. You want things happening in awake before they happen in start. So yeah, if you've got 100 game objects and you want all of them to do something before another script executes, put that one script into start and all of the other ones into awake. And then it comes into stuff that happens every single frame or every single every single frame basically. There's update, which is what we're most used to here, update here. But then there's also fixed update. The difference is that fixed update happens once per frame, kind of regardless of the actual time. Wow, this part's new. This has to do with the internal animation system. This has to do also with the animation system, but the important one here is fixed update, which happens before update, which is here. And there's also on trigger and on collision, which are events that get fired whenever you've got a collision between two game objects. And then you've got this yield wait for fixed update. That's basically a timer that keeps track of your coroutines. We talked a little bit about coroutines last week. We'll get into them more tomorrow or on Thursday probably. On mouse is handles events usually pertaining to where your mouse is on the screen. Update, probably the most important. Well, yeah, start and update are equally important. It's one of the reasons why whenever you create a new mono behavior script, let's turn this off. Whenever you create a new script here, it automatically generates those functions. You don't necessarily need those functions. A mono behavior script doesn't need anything really, but it automatically gives you start and update because more than likely one of those is going to get used. You're either doing something every frame or you're doing something right when the scene starts to get fired up. Remember, awake happens before start. Let's go back here and keep going through our flow. This one's important. There's one other important diagram I'll show you guys pertaining to collisions and rigid bodies. Was there a question?
One question.
Yep.
Yes. Regarding the flow, what I see is that basically you as a developer, you don't have to keep an eye on, this loop and the computer resources that you need, because basically you always think that, fill this loop, but when do you have to put your attention on the computer usage on every iteration, of putting animation on every iteration? When do you need to put an eye on this?
Yeah, it's going to happen automatically. So Unity, as I was kind of explaining last week, is single-threaded. It handles all of the multi-threading for you with this big game loop here, with the game logic loop, and you handle multiple threads using coroutines, which can be controlled with this wait for fixed update function. Does that answer your question, or I feel like I could maybe give you more, or you're kind of hoping for more?
Okay. So in that wait for fixed update is when Unity makes all the work to validate if the function it's useful to be added to the
heap.
I don't know, to the stack.
Yep.
Yeah.
The heap. It's the heap, but yeah.
Okay.
Yeah, they're all
Okay,
kind of running at the same time. So all of these scripts that are attached to our game objects, they are constantly, every single frame update is getting fired. And so it's one of the reasons why you don't want to use GameObject.find in your update, because GameObject.find traverses everything in your hierarchy, and that's really one of the surest ways to kill your game performance is to use GameObject.find, even though it can be a useful function. Only use it in start or awake, because yeah, update gets run all the time, and Unity's optimized so it usually runs pretty smooth. You have to have a lot of stuff going. The other thing that kind of kills performance is if you have a collider that has lots and lots of edges or polygons. Usually you kind of want your colliders, especially your 3D colliders, to either be like a capsule or a box or something that doesn't have so many surfaces. You can kind of cheat or fudge some of your edges. And so even if you've got a hand, you don't have to have something for every single finger. Your hand can basically be like a box, and it's a lot more computationally, computationally less expensive if you've got a hand that has a box collider rather than colliders for each individual finger. Unless you really need that type of.
And what about video rendering?
Oh, video rendering.
What about video rendering? I mean, if you think on VR, and you can have a very small video of 720 pixels, but what if you have a video that is 8K, for instance, and how Unity managed that?
Ooh, 8K is huge.
Yeah.
I don't even know how Unity would handle that. 8K is really, really big. 4K, Unity can definitely handle that. But yeah, Unity has a video player component that's built right into it. They might even have it in the drop-down, maybe? Game object, video. Yeah, you can just drop a video player just about anywhere. Yeah, you can have it play on top of something. Otherwise, you can have it like a billboard, so it's just kind of playing within a window within your game. But yeah, that's how Unity handles video. It used to be a lot harder. There wasn't a video player back in Unity 4, and so, or actually, I think they had it, but it was part of their paid Unity version, and so yeah, they've just included it by default now, and it's a lot easier to add and to use.
All right.
Yeah. Let's get back here. We're almost through our game logic, primary game logic loop here. Again, we've got coroutines and yields. Yield is how you do multi-threading. If you're waiting for something to come back from the internet, or if you're waiting for a certain number of seconds, or you're starting a new coroutine, those all happen here. This is, again, stuff for handling animations. These gray box ones aren't quite nearly as important as the ones that are just in white. And then at the very end, then you do late update. If you want something happening after update, late update is where you put it. This is where you do special rendering things. I'm not very familiar with this. This is how you do fancy shading and fog. And well, actually, a lot of the fog stuff can be done very easily and auto-generated. But if you want to really optimize the look of your scene, you can use these functions. Gizmos are, again, just editor-related things. On GUI is called multiple times per frame. So this is basically for updating your GUI. Yeah, you don't want to put any 3D or physics-related things on GUI because it's trying to do it basically all the time. Whenever it's not processing something it's doing on GUI. Wait till end of frame is another yield coroutine related function. On application pause. I've never used that one before, but I think this will trigger whenever you pause your game, either through this pause button or I'm not sure if Unity has an actual pause function built into it now. On application quit is one I have used before. Basically, if you want to have the player be able to save their game or something before the application quits, you would put that into the component, into the class. Teletech should even find it for us on application quit. Yep. And you would put that there. Again, you don't have to have it. You can leave it blank. If it's blank, you might as well just remove it. On disable, I've used before for sure. If something gets turned off in the hierarchy, you can you can manipulate it with the checkboxes here. But sometimes, remember last week we were turning our camera off. If you want something to happen when something gets shut off, then you can use this nifty on disable function, and whenever it gets turned off or something else turns it off, it will fire on disable. And same with on destroy. The difference between disabling and destroying: unchecking is disabling. The delete key is destroying. Hitting delete, or you can delete things. There's a function in Unity called GameObject.destroy, and this will destroy whatever you put into parentheses. GameObject.destroy, or even destroy immediately, because I think destroy waits until the end of the frame. Destroy immediate gets rid of it immediately, and you can put in any game object. If you want to destroy itself, then you do this. Actually, destroy this is a useful function if you've got something that's spawning new, I don't know, bad guys, and those bad guys wander off the screen and you're never going to have to deal with them ever again. It is a good idea to destroy them after 10 seconds or whatever if you're never going to see them again, just because it is another memory management issue where, if the player's playing the game for a really long time and you're generating, new enemies every 5 seconds, but, they wander off the screen and you aren't going to have to deal with them again, the game is still keeping track of them in memory. And so you're better off destroying them so that it frees up memory. Otherwise, yeah, if you've got a million bad guys because you've been playing for a really long time, that's gonna slow your game down. Game object is kind of blued out. It's not as dark as this color blue. That's because it's kind of optional. It assumes, it's kind of like when you put the word this in front of something and it knows that it's this already. Because you could do this dot and then you get all of the functionality from mono behavior, or from mono behavior. And mono behavior also gets from game object. So if you want to have any of the game object functionality, that's all there at your disposal. And I should point out there is a big difference between game object lowercase and game object large case. Game object little, starting with the lowercase g, is referring to the game object yourself. Whatever game object this component is attached to, it's referring to that specific game object. If you have game object capitalized, you get a whole different set of functions. This is kind of like the global game object. If you want to instantiate new prefabs, if you want to destroy things, if you want to do game object.find, this is kind of the global game object. And it even changes colors for you too. Local game object, little case blue. And you get different functions. Same is true with transform. So if I do lowercase transform, you're referring to your own transform. Whatever game object this component is attached to, it's talking about its local position or its local parent or its local size. If you use uppercase transform, you get different functionality. Usually, yeah, there's not even that much. You can basically destroy or find. I don't even know how instantiate would work. I guess you can instantiate this way. My guess is that this function is even inheriting from somewhere like game object. Yeah, object. So, yeah, those are the. That's a lot of useful information to have about the game flow and just how Unity does transforms and game objects and things like that. If you want to get into further detail and descriptions, actually, it's not even that descriptive. These are actually kind of nice, concise, like what does this actually do? You can look at those down here. Yeah, let's go back to our player controller and kind of break down what's going on. These are the different audio clips and properties and things that can be found in the inspector. Platform model. This is interesting. Let's look at it on the in the inspector. Looks like it doesn't show up. You know, it's not public. It's read only. And so if we want to see what this platformer model is, it looks like it's got a cinema machine. It's basically a reference back to our platformer model. Yeah, I think it's basically just for reference. So rather than writing this long thing out, you can just say model. Although I don't really like calling it just model because it's not a very descriptive variable name. There's the on enable function that we wrote. I don't really need that. I'm not sure why they modified this function. Usually you just have to do private void update. At any rate, this is update. This is happening every frame where as long as your controller is enabled, it's going to read whether or not you're pushing left or right. It's going to read whether or not you got the jump button. If you're pushing the jump button and you are on the ground, then you set the state to prepare to jump. And this is all for animation related things. It doesn't have to be nearly as complex. Well, this isn't that complex, but yeah, sometimes you just need two states. You either need jumping or not jumping. In this case, we've got grounded and we've got jump and we've got prepare to jump just because our guy's got a little more animation. Stop jump is probably getting set when you get to the peak of your jump. This is also calling update jump, and it looks like we are overriding some kind of jump. It's must be inheriting. It's inheriting from kinematic object instead of mono behavior. So kinematic object also inherits from mono behavior, so that's why you get all of the mono behavior functionality. But this is keeping track of additional information like velocity and our normals and things. They're physics-related properties that can be used to control the cinema machine. Scrolling down further here. people are probably familiar with switch statements. Switch statements is similar to if you were to write if jump state is equal to prepare jump, if jump state is equal to jumping. Yeah, it's like a big if then else statement, but it's a little easier to read. Yeah, this controls your jump animation. They broke it out into its own little separate function. There is complete velocity, and this is, yeah, where stop jump probably gets set to equal to true somewhere, or false. Yep, true and false. Here's our different jump states. I like to put the enumerations at the top myself, but they decided to put them down here at the bottom. Yeah, it's the player controller. Let's look at one more class. Let's go look at the bad guy controller. It was called, I think, enemy controller. Enemy controller. Not quite as long as the player controller because they don't really do as much. Basically, there is a on collision where it's kind of waiting around, listening to see if the player jumped on them or if the player ran into them. And also moving him back and forth. So if he has a path, then move that guy back and forth every frame. Trying to see where it actually has the angle. It's got to know somewhere whether or not if the player is jumping on his head or if he's jumping on or running into the side. Let's zoom in on one of these enemies. Yeah, they've only got a single capsule collider here. Yeah, the logic for that's got to be somewhere. Could maybe see if we do get lucky and find it with a global search, land on enemy. No, there's no land on enemy. Yeah, I kind of thought the logic for that would be in here. They have a separate class for it. They put it into a player enemy collision class where we've got this function here, will the enemy hurt me? And so you kind of determine based on the player's collider and the enemy's collider, if the player is above the enemy, if their value is higher, if you're above the enemy, then you're going to get hit. Otherwise, you're not. And so there's the logic for that. Yeah, looks like if you get hit, causes death automatically. Thought I saw hit points in there somewhere, but yeah, I think we might have to change the logic around a little bit. Yeah, it looks like they have it commented out because in a lot of games, if you get hit, you start flashing, and because you don't want to hit the player again, in the next frame, and so you typically give the player a little bit of, a quarter second or a half second of invulnerability, so you don't immediately get hit again and again after you've run into something bad. Yeah, do you guys have any questions? We're kind of coming up on our time. The class is supposed to be 2 hours. We've got, yeah, probably a half hour left. But I was going to give you a few things I wanted you guys to see. First, if you can change the slimes into different colors. And then the second challenge would be to set multiple respawn points. So if you make it, let's say, over to this second platform, that the respawn point gets either moved to that different location or just have a second respawn point called respawn point 2. And then, yeah, the player will respawn at the new respawn point so that if you die, you don't have to go all the way back to the beginning of the level. Because this level looks pretty epic. I don't know if you guys have been playing it at all or if it, yeah. Maybe it's easier than it looks, but yeah, I think the goal for the next 15-20 minutes is to change the color of the slimes to something different other than red, and then to add additional respawn points so that if you die, you go back. You don't necessarily go back to the beginning. You go back to a point that's to the previous respawn point that you passed. So yeah, why don't you go ahead and try that out. Yeah, I'll stop sharing my screen now. I'm gonna go get another Mountain Dew, and we'll reconvene here in 15 or 20 minutes. So yeah, the goal is to turn the slimes into different colors, or a different color. You could even set them individually if you wanted to, but the easiest way to recolor them all is through by changing the prefab, and then to set up the multiple respawn points. Is there a question? Okay. And then I'll do it on mine as well. Ooh. I'm looking at, looks like because the blob is using a sprite render instead of a material, it's more difficult. It might be more difficult than just dropping a new material on there. Let me see if it's possible here. Yeah, it doesn't look like there's a real easy way of changing the color of the enemy. Now, I tried changing my material to just blue, but then it makes the enemy not look very good because there's actually a transparency that goes around it, and the transparency ends up getting colored blue. So that is a little trickier. In order to be able to do that, we would have to have new sprites. You'd basically have to have your graphic designer recolor it with a graphic design tool. So let's go ahead and turn that back. So yeah, we're at 7:30 here. I'll start sharing my screen and show you guys how we probably go about doing this. All right, so what I did already was I added 2 more spawn points. And I also added some tags. So what I didn't show you guys so far, and it's kind of like a gizmo. It might even, yeah, it is a gizmo. If you come up here in the inspector, you can select one of these cool looking icons. Normally the default is none, but if you want to make little labels, you can click on a label. It can be different colors, it can be diamonds. And in this case, because there's no sprite render or anything on our respawn points, thought it'd be easier to kind of visualize and see where the spawn points are, and so that's why I added this. And this is, really the utility of Gizmos, is that you can have something show up when it's not actually there. So I added this, gizmo to this game object, and then I hit Control D and I duplicated 2 additional respawn points, and then I just moved the X position of the other 2 points so that they're a little further along in the level. So here's, the first one is back here at the beginning, second one's here, third one is here. So we've got the respawn positions in our scene. Now we've got to kind of build it into our actual game controller. So back here, our game controller was before only keeping track of a single respawn point. But what we want to do is we want additional points. And so we come over here to our game controller. The game controller has a platform model. And inside of the platform model, this is where we have our spawn points. So we're going to have spawn point 2, and spawn point 3. When we save it and we come back over to Visual or to Unity, those new spawn points will show up here in our inspector, and we want to go ahead and drop these new spawn points here so that the code knows which ones we're referring to. This is kind of the link between the game objects themselves and the code. They're just references. And so now we can go back into our code. This spawn point was being referenced actually only in a single spot. It was being referenced inside of execute. There's a teleport function actually that moves the person. So basically, depending on how far they are, we'll go to a different respawn point. So we could almost copy and paste this, and rather than going to spawn point 1, go to 2 or 3. But we also need a little more logic in here to know which one to use. It'll be again a switch statement. So switch, and it seems like we're probably going to have to introduce some kind of new variable in order to keep track of how far along the player is. So probably the most logical place to keep that is going to be the player controller. Let's go back to the player controller, and we're going to keep a variable called progress. And yeah, we'll put progress here. Normally we probably wouldn't want to make it public, but just so we can see it in the inspector, we'll make it public. And player progress. Put that there. And inside of player progress, even inside of update, whenever you move, we're going to be wanting to update our player progress. As long as it's not going the wrong way, as long as we're not going backwards, we can update player progress. So let's do player progress is equal to our transform dot position dot x. But we also don't want it to go down, so let's do if player progress is greater than or is less than our x position, and we'll update it. So yeah, if we've made progress in the x direction, then update our player progress. And so now, as long as we don't have any compilation errors, let's get rid of this switch statement real quick so we can just test and make sure and see that that variable is being updated correctly in the inspector. We can look at our player controller. We scroll down and looks like player progress is 0. Oh, look at that, it works. See how player progress goes up whenever I move to the left or to the right, and if I move to the left, it doesn't. So this is a good way of keeping track of how far we've made it without dying. Oh, I died. So now it actually respawned us at the furthest respawn point because we didn't get that logic written yet. If we go back, the code did what it was supposed to do, but we didn't have it programmed to do the right thing because it first teleported us to the first spawn point, then immediately transported us to the second, and then finally the third one. We want to do a little logic here with our switch statement that's based on the player's progress. What do we call it? We called it player progress. Player progress is, yeah. Actually, I don't think you can do a switch statement with floating point. So I take this back. So if player progress is greater than, I think it was like 30, then we actually get to go to the furthest point. Else, if it's greater than, I think it was about 10, and this we can actually go back and check in the inspector, and it does this. Otherwise, you go all the way back to the beginning. We are missing an if. Go back to the inspector, double check these spawn point locations. Looks like this one was at 27.8. So basically, if you get to 28, they go there. Otherwise, this one's 39, basically. We go there. And so now it looks like it should be working. Let's hit play and test and make sure that our respawn points are working all right. And then we'll open it up one more time for questions and then call it a night. So, oh, we're not very good. We died. Oh. That did not behave how I anticipated. Let's look at our player progress. Oops. Player progress is ticking up. It's only at 5. This is where we can, let's go ahead and turn on our debugger and see what exactly is happening when we hit this line of code. Is it something we miscalculated, or why in the world did it not respawn at the right spot? Let's make sure. Yeah, the debugger is going. A lot of programming is just debugging. Something behaves awkwardly. We hit it. So, it doesn't do that. It doesn't do that. So then it respawns. Oh, because I had position 2. I had my my code written wrong. That's why. So let's go ahead and come back and fix our code. This is supposed to be respawn point 0, and this one right here is supposed to be 2. It's a little typo, but that's how you introduce bugs to your code. So let's give it one more test, I guess. Dies, respawns back here. Let's play the game. Hopefully I can survive. Ooh. To at least the second spawn point. Right now you can see my player progress down here is 20. I think the magic number to get over here is 28. So hopefully this slime doesn't kill me here. Oh, this is being recorded too. Here we go. All right, we made it over 28. So now, if I die, I should be respawning right here where I just died. Very good. And maybe, I think the next one was 38, so we should now be respawning at our third and final save point. So, yeah, do you guys have any questions about how I did that? Is it clear how the code is interacting with the properties that you set in the inspector? Yes, hopefully. All right, well, I will put a link to today's recording. We recorded the video today. We recorded the one last Thursday as well. I'll put links to those in our Slack channel. If you guys have any questions, you can get a hold of me through the Slack channel. Otherwise, yeah, we'll just plan on meeting same time, same place on Thursday. Thanks.